We have a question that says 1 gram of calcium carbonate was treated with excess 0.1 molar HCl. At the end of the reaction, the acid left unreacted required 25 cm³ of 0.1 molar sodium carbonate to neutralize it. What was the original volume of the acid? Given that sodium is 23, calcium is 40, carbon is 12, oxygen is 16, and chlorine 35.5. This was taken from 1980, question 8. The first thing we want to do is that we're going to find the number of moles of HCl that was consumed in the first reaction. The reaction is in 2 steps. The first reaction was when CaCO₃, which is calcium carbonate, reacted with HCl. Alright? And then the second reaction was when sodium carbonate now reacted with what was left. That's the excess that was left from the reaction of calcium carbonate. So it reacted with the same HCl. Now, in order to get the product of the reaction, we're going to use the idea from acid, base, and salt, given that whenever carbonates react with acids, they are going to give the salt of the positive metal ion, and then water and carbon dioxide gas. So the positive metal ion in this case is calcium. The salt of calcium, we have CaCO₃, which is calcium chloride. This is going to give us water and carbon dioxide gas. We have 1 mole of calcium here. We have 1 mole of calcium, so calcium is balanced. We have 1 mole of carbon, 1 mole of carbon. Oxygen here is 3. 1 plus 2, that's equivalent to 3. While here we have 1 mole of hydrogen, 2 moles of hydrogen. So we're going to put 2 here. So this makes it 2 moles of hydrogen and 2 moles of hydrogen on either side. Then chlorine is automatically balanced as 2 moles of chlorine on the reactant side and same thing on the product side. Then we'll still get the product for this reaction. So the same thing. The corresponding salt when sodium carbonate reacts with HCl, we're going to have NaCl plus, because sodium is a unipositive ion, there is no 2 attached to Cl, so we're going to have H₂O plus CO2. Alright, so sodium here is 2, sodium here is 1. We'll put 2 here. Alright, carbon here is 1, carbon here is 1, that's balanced. Oxygen is 3, oxygen is 3, is balanced. Hydrogen is 1, hydrogen here is 2. So we'll apply 2 here, and then chlorine automatically balances as 2 moles of chlorine here, 2 moles of chlorine here. Now, the question says 1 gram of CaCO₃ was reacted with excess 0.1 molar HCl. Let me write out the first reaction because that's what we're going to use, right? We have CaCO₃ reacting with 2 HCl, right? So giving us CaCO₂ plus H₂O plus CO2. Now, based on this reaction, 1 mole of CaCO₃, there's no number here, meaning that it's actually 1 that is here, right? So 1 mole of CaCO₃ will react with 2 moles of hydrochloric acid to yield 1 mole of calcium chloride, 1 mole of water, and 1 mole of carbon dioxide gas. So we have 1 mole of calcium carbonate must react with 2 moles of hydrogen chloride or hydrochloric acid to give 1 mole of calcium chloride, 1 mole of water, and 1 mole of carbon dioxide gas. So in this case now, I said 1 gram of CaCO₃. So we're going to convert this 1 gram of CaCO₃ to moles, and then we're going to find the number of moles of HCl that was produced. So write out number of moles. Alright, it's one of the basic formula for stoichiometry. Number of moles is mass over molar mass. Alright, this mass where m is equals to mass of, could be the mass of the elements, like in this case was mass of compound, so it can be mass of compound. Alright, so is it a mass of an element or the mass of a compound that was given? Then y molar m is equals to molar mass of elements or molecular mass of compound. So molar mass of elements or compound. So in this case, we're giving 1 gram of CaCO₃. CaCO₃ is a compound, so that's the given mass. So we have, for this case, m to be equals to 1. That's for CaCO₃. For CaCO₃, we have m to be given as 1. As for the molar mass, we're going to calculate CaCO₃. How are we going to find the molar mass of CaCO₃? Calcium, the given in question, was 40. So add 40 plus carbon, still given, was 12. Then oxygen was given as 16. We're going to multiply 16 by 3 since it's 3 moles of oxygen that is in 1 mole of calcium carbonate. So that gives us 16 times 3. Of course, if you add everything together in your calculator, you're going to get 100 gram per mole as the molar mass of calcium carbonate. And then the given mass was what? 1. So we now have number of moles to be 1 divided by 100, which will give you 0.01 mole. 0.01 mole of CaCO₃. Now, going back to this reaction, we said that 1 mole requires 2 moles of HCl. So we now write, if 1 mole gives 2 mole, or it requires 2 mole of HCl, then 0.01 mole will give x mole of HCl. X mole of HCl. Alright, to get the value of x, we're going to cross multiply 1 times x. That is, of course, going to give us x, and 0.01 times 2 is equivalent to 0.02. So that's 0.02 mole of HCl. Alright, as for sodium carbonate, which was Na₂CO₃, let's rewrite the equation. Na₂CO₃. We said when it reacts with HCl, it will react with 2 moles of HCl to give 2 NaCl plus H₂O plus CO2. Alright, so the ratios here, mole ratio is the same thing, 1 ratio 2, or in this case now we have 2 for number of moles of HCl. That's not really our business, but we just write everything down. So we have 1 ratio 2 ratio 2 ratio 1 ratio 1. Now all we're concerned with is sodium carbonate and HCl. As for sodium carbonate, we want to find the number of moles. So we find the number of moles and the amount of HCl that we produce. Now, to get the number of moles from concentration, which is 0.1 molar, and volume, which is 25 cm cube, we use a formula. The formula is that N is equals to CV. N is equals to CV. What does C represent? Where C is equals to concentration. C is concentration in, you must have a unit, mole per dm cube. Concentration in mole per dm cube. While V is volume. V is volume in dm cube. Alright, so when you multiply concentration in mole per dm cube by volume in dm cube, take note of the unit. Alright, we are going to get number of moles. So for the question, if you look at the question, they said that 25 cm cube of 0.1 molar Na₂CO₃. So the first thing we want to do is that we want to convert cm cube to dm cube. This 0.1 molar is a symbol that you can use to represent your concentration, and whenever you are given molar, capital letter M, it is already in mole per dm cube, so we don't have to bother about this concentration. But as for cm cube, in order to convert cm cube to dm cube, you are going to divide it by 1000. So the reason is that 1000 cm cube is equivalent to 1 dm cube, alright, which is also equivalent to 1 liter. Right, so just take note that 1000 cm cube is 1 dm cube, which is 1 liter. Now we have 25 cm cube, so 25 cm cube will now be equal to x. So we simply cross multiply. We have that 1000 multiplied by x is equals to 25. Right, we didn't need to bother about the units because we are aiming for dm cube. So we're going to have that x, when we divide both sides by 1000, x is 25 over 1000, which when you divide you get 0.025 now in dm cube. Alright, then to get number of moles, remember we said concentration times volume. This is volume, so this is equals to volume now in dm cube. So we'll have 0.1 times 0.025, which if you do that, that'll give you 0.0025 mole. What did they ask for? They asked us for the excess volume that will be left. Now remember I said that number of moles is concentration times volume. So if I make volume subject of formula, we can say that volume is number of moles over concentration. Now to find the original volume of the acid, we need total number of moles divided by concentration of the acid. The concentration of the acid was given to us. If you check the question, it was 0.1, but I'm just chipping this in, right? What do I mean I'm chipping it in? We're not done finding number of moles, because the number of moles we need to find is both the one consumed when reacting with Na₂CO₃, which is sodium carbonate, and calcium carbonate. So first off, we have 0.025 mole. So we'll write from the equation, which let's write that, which we obtain as Na₂CO₃ when reacting with HCl. We have plus 2 HCl. This will give us 2 NaCl. This is already balanced equation, plus H₂O plus CO2. So if you observe, we have that 1 mole of sodium carbonate, we require 2 mole of HCl. So 0.0025 mole of sodium carbonate will require X mole of HCl. Alright, so this is a much faster way of obtaining number of moles of HCl. So if I cross multiply, I obtain X as 0.025 times 2, which is 0.05 mole of HCl. Now I'm going to use this formula now that volume is number of moles by concentration. So first off, the volume we are dealing with is volume of original HCl. For original HCl will be a sum of number of moles in both reactions, sum of number of moles divided by concentration. They give us concentration in the question as 0.1, right? Here is 0.05, 0.005. That's 0.0025 multiplied by 2. So this is 0.005 mole of HCl. So the sum now becomes 0.005 plus, if you add the number of moles of HCl we got for CaCO₃, which was 0.02, right, divided by 0.1. So let me punch that in. We're gonna have 0.005 plus 0.02, which is 0.0025. So this is equals to 0.025 divided by 0.1. And if you dividing this by 0.1, we're going to obtain 0.25. So we have this is equivalent to 0.25 dm cube. If we check the original question, we had our options in cm cube. So to convert dm cube to cm cube, remember we said that 1000 cm cube is 1 dm cube. So we can just see that 0.25 dm cube will be equivalent to x cm cube, which is 0.25 times 1000. So x is equals to 250 cm cube, and that is the correct answer. So the next question says, pure sulfuric acid is a liquid of 1.84 density. What volume of it will be required to prepare 250 cm cube of 0.2 molar solution? From question 1, we said that molar is concentration in mole per dm cube. 250 cm cube is volume, and we're given density. Alright, first we need to establish is that we have density to be mass divided by volume. Alright, we have the formula relating concentration and volume is that number of moles N is equals to concentration and volume. Right. So the question says that we should find what volume will be required to prepare 250 cm cube of a 0.2 molar solution. Now, the volume that we're being referred to is the one in the formula for density, which is that density is equal to mass over volume. So we're given concentration for the solution, we're given volume of a solution. We can find number of moles by saying that N is equal to CV. First off, we say volume, which is in 250 cm cube, will convert to dm cube by saying that volume in dm cube, right, will be 250 divided by 1000, which will give you 0.25 dm cube. That's the volume of the solution. All right, now 0.25 dm cube is volume. We're going to multiply it by 0.2, so N becomes 0.25 times 0.2. If we do that, we're going to have 0.25 multiplied by 0.2, which is equivalent to 0.05. So we have that this is equals to 0.05 mole. Now, I know you're asking like, okay, they gave us volume already of a solution. Why ask us to find another volume? This is of another different solution. Okay, these two solutions are different, but they are trying to establish that since it's the same sulfuric acid we use in a different solution which had a density 1.84, and in this solution now it had concentration 0.2 molar when volume was 250, we can be able to relate both of them because of this common sulfuric acid, but they are different solutions we are talking about. So this is 0.05 mole. Now, to convert mole, we need to convert mole to mass because that's where we can impute density equals to mass over volume. So to convert mole to mass, we say that N, as we said in question 1, is equals to mass divided by molar mass. The molar mass of sulfuric acid, which is H₂SO₄, all right, H₂SO₄, is made up of 2 moles of hydrogen, that's 2, which is 1 times 2, plus 2 moles of sulfur, 1 mole of sulfur, sorry, that's 32, plus 4 moles of oxygen, which is 16 multiplied by 4, that gives us 64. So everything added, that's going to give us 98. All right, so we'll now see that mass, which is mass of sulfuric acid, is now given as 98 times 0.05. And if you compute that, we're going to have 98 times 0.05, which is now 4.9 grams. So this is equivalent to 4.9 grams of H₂SO₄. Alright, so the question says, what volume of it? So the volume in density, right? So meaning that volume V, making V separate a formula from here, we're going to have V is equals to M over D. So mass will go as 4.9, while density they give us as 1.84. So let's punch that into the calculator. We have 4.9 divided by 1.84. So that gives us 2.663 grams. Now, based on the options, we're having 2.00, 2.66, 3.00, 3.66. So we're going to approximate this to 2 dp. First decimal is 2.7. Second decimal is 2.66. So second decimal is safest, 2.66 dm cube. Alright, so that's 2.66 dm cube of H₂SO₄. So the correct answer here is option B.